Hello everyone, welcome to my channel. This is Learning Ramen, and today we're going to learn how to simplify radicals. Before we start with our problems, it's very important to understand the following. First is the rules, then your table of perfect squares, perfect cubes, and why is it important? Because this is the prerequisites of simplifying radicals. So what are we waiting for? Let's start. And we have our question number one, square root of 18. So first thing that we need to do is to factor it out since 18 doesn't have any square root, but it has a factor that is a perfect square. So looking at our table here, we have 1, 4, 9, 16, and we know that 9 is a factor of 18. So we can rewrite our 18 into 9 times 2. Then, using the product rule of radicals, we can rewrite our square root of 9 times 2 into square root of 9 times square root of 2. Then, we simplify. Square root of 9 is 3, and square root of 2 is square root of 2 only, because 2 doesn't have any square root. And this is our simplified form. For the question number 2, we have square root of 75. Again, feel free to pause to answer it on your own or try it on your own. Then just play again if you would like to check. So we have square root of 75. So among these perfect squares, what is the factor of 75? It's 25. So we can rewrite the 75 into 25 times 3. Then, using the product rule of radical again, we can rewrite our square root of 25 into square root of 25 times square root of 3. Then, we simplify. Square root of 25 is 5, and square root of 3 is just square root of 3. And that's our simplified form for the square root of 75. Now for the question number 3. Here we have a variable that is x raised to 4, and we need to get the square root of it. So as you have noticed, there is no index on this radical. So the number that we have here is 2. That's why it's called square root. With that, by the use or by the concept of fractional exponent rule, we know that we have a numerator and denominator if we're going to change this radical form into fractional form. So let's rewrite x raised to 4 because that is your exponent. Then the index becomes your denominator. Okay, so we know that we can simplify 4 divided by 2, and that is equal to 2. And since our exponent is a whole number, we don't have any radical anymore. That's why it's x squared. Okay, so this is our simplified form. Next, question number 4. Again, we don't have a number here, so the index is 2. Then we were going to rewrite our x raised to 7 into a number that can be divided into 2. Using your product rule, we're going to break the x raised to 7 apart by rewriting it. So what is the closest number to 7 that is divisible by 2? And it is 6. So we can rewrite the x raised to 7 into x raised to 6 times x raised to 1. Because using your product rule, we know that when we add the exponent together, it will go back to x raised to 7. Now, using the product rule of radicals, we can rewrite it as square root of x raised to 6 times square root of x raised to 1. Then, we can rewrite the x raised to 6 over 2, because again, your index is 2 and the index is 2, multiplied by x raised to 1 over 2. Then we have 6 divided by 2 is x raised to 3. So we have an exponent of whole number. So we will not have any radical already. But for the 1/2, since we cannot simplify the 1/2 anymore, we will write it again on the radical form, which is x raised to 1 with the index of 2, or x cubed times the square root of x. And that's your simplified form. For question number 5, this is a combination of a number and a variable. So let's do it step by step. Again, we have an index of 2, but we need to factor the 45 first. Among these perfect squares, we know that 9 is a factor of 45. So we can rewrite the 45 into 9 times 5, and the x cubed, since 3 cannot be divided into 2, we need to break the x cubed into two parts. So we have x2, since 2 is the closest number to 3, that can be divided into 2, times x raised to 1 equals, we need to use the product rule of radicals by rewriting square root of 9 times square root of 5 times square root of x squared times square root of x. And here, we know that square root of 9 is 3 times square root of 5 times the square root of x squared is just 2 divided by 2 to the index. So exponent divided by the index using your fractional exponent rule again. So that will give us x raised to 1. Then we have exponent of 1, index of 2. Since we cannot divide it anymore, it stays inside your radical. Now we're going to combine everything, and that's the simplified form. So 3 and x, since they are all outside the radical, so we will combine them, 3x. And what will remain inside your radical is the 5 and x. So 5x. And this is your simplified form. For question number 6, feel free to pause to apply what you have learned so far. All right. Square root of 200 x raised to 5. Again, the index is 2. And we can rewrite the 200 and x raised to 5. 200 is factorable by 4, factorable by 25, and factorable by 100. So in this case, since we have three perfect square factors for 200, we need to pick the highest factor. 100 times 2 times, since 5 cannot be divided into 2, we need to break the 5 into two parts. X raised to 4, since 4 is divisible by 2 and is closest to 5, times x raised to 1, which we're going to multiply, it will go back to x raised to 2. Now that we have our factors, we can rewrite. Now let's simplify and combine all the radicals and the whole numbers that we have. Square root of 100 is 10. Square root of 2 times x raised to 4. The index is 2, so numerator divided by the denominator, which is 4 divided by 2, is just x raised to 2. Times the index is 2. 1 divided by 2 cannot be, so we write it again inside the radical. 10. Let's combine the 10 x squared times square root of 2x. And that's our simplified form. For question number 7, here we have two variables, but it follows the same format, factoring, then break the exponent into parts that is divisible to the index. If it is already divisible to the index, then need to break it apart. So going back to our factoring, 20, the index is 2, and 4 is a factor of 20. So we will rewrite the 20 to 4 times 5 times a raised to 2 times a raised to 1, because 3 is not divisible by 2, times b4. I will not break it apart because 4 is divisible by 2. Now we need to rewrite our factor form to square root of 4 times square root of 5 times square root of a squared times square root of a times square root of b raised to 4. Then we simplify. Square root of 4 is 2 times square root of 5 is square root of 5 times 2 divided by 2 to the index, that is a raised to 1 times a raised to 1 half, so it stay inside the radical, times the index is 2. 4 divided by 2 is b squared. Now we have all the whole numbers and variables. We rewrite it together to a times b squared. And we will group or rewrite all the numbers and variables inside the radical, which is 5a. And this is your simplified form. 2ab squared times 5 times square root of 5. Question number 8. Cube root of 16x4. So this is not a perfect square anymore, but a cube, but we change our table into cubes as well. So it follows the same format. 8 is a factor of 16. We rewrite our radical to 8 times 2 times, since 4 is not divisible by 3, we need to break it apart. 2x raised to 3 times x raised to 1. Then, product rule of radicals, we rewrite cube root of 8 times cube root of 2 times cube root of x cubed times cube root of x1. So here the cube root of 8 is 2, as you can see here. Cube root of 2 doesn't have any, so it stay inside your radical. The numerator divided by denominator is 1 times 1 divided by 3 cannot be, so it stay inside your radical. Then we combine 2x times cube root of 2x. And that's your simplified form. Next, question number 9. Cube root of 54 times x raised to 11. So we know the index is 3. That means it's a cube root. So let's go with a factory. 54. Factors of 54, it's not 8, but 27. So we can rewrite 54 to 27 times 2. Then x raised to 11, we know that 11 cannot be divided into 3. So what is the closest number to 11 that can be divided into 3? It's 9. So x raised to 9 times x raised to 2. Now, using the product rule, we will going to rewrite, but don't forget your radical index. Cube root of 27 times cube root of 2 times cube root of x raised to 9 times cube root of x raised to 2. Cube root of 27 is 3 times cube root of 2 times numerator, which is 9, divided by denominator, which is the index 3, x raised to 3, times 2 divided by 3, cannot be, stay inside the radical, equals 3x cubed times the cube root of 2x squared. And that's your simplified form. Next, bonus question. Here we have a fourth root, but our table is perfect square. So if in case you encounter this kind of question, you need to create your own table by remembering again your roots. Since we have a fourth root of 4, we're going to create our own table. 1 raised to 4 is 1. 2 raised to 4 is 16. 3 raised to 4 is 81. So we know that the factor of 32 is 16. So we will going to rewrite our 32 to 16 times 2 times. I will not break the 8 because it is divisible by 4. So it remains x raised to 8 times 5 is not divisible by 4. So I need to break it apart. 4 is the closest number that can be divided to 4. Y raised to 4 times y raised to 1. Then 16 inside the fourth root times fourth root of 2 times fourth root of x raised to 8 times fourth root of y4 times fourth root of y1. So here we know that the fourth root of our 16 is 2. It goes outside the radical. Fourth root of 2 doesn't have any, but 8 divided by 4 is 2. So we rewrite x squared, and 4 divided by 4 is 1. So y raised to 1. Radical with an index of 4, we rewrite 2 y1. And this is your simplified form. I hope this video helps you remember or learn how to simplify radicals. If you find this helpful, don't forget to subscribe and hit the like button. Thank you, everyone.